trust, one of the most important assets on the internet. So what would we be without trust in the internet? Just imagine there is a web shop. How can you trust that it's trustworthy? How can you believe in what they're saying? There's someone who's sending you an email. How do you know it's a guy who he says he is who is sending this email? That's all about trust. And if we look back into 2011, what have we seen? Some of the certificate authorities, the trust was broken by faults, by failures. And that's what I'm going to talk about today. Is trust a real problem in the internet, and how we can overcome this problem? And I'm glad you're here this afternoon, where on FOSDEM there are so many interesting talks, and I'm glad the room is overfull. So there's still one seat here if someone of you want to sit. No? Okay. So anyway, I will start. I will start with introducing myself a bit, because actually it's always good to know who is speaking. And that's me. I'm Benedikt Heintel. You have seen it on the first page. Actually, I studied business administration and computer science on Darmstadt University of Technology in Germany. And I graduated last year. I had a major's IT security and cryptography. So actually, it's all combined in this topic I'm talking about today. Actually, right now I'm working as a consultant for a European company. Actually, it's a French company with branches all over Europe. And my major topic I'm working, my day-to-day work, it's all about IT governance, IT security, trust, data privacy, everything that has to do and is related to the things I'm talking to about. So if you have any question during the talk, please shift it to the end, because I hope I can answer the most questions up front. But if there are any, I put in a Q&A in the end. Right now, what are we going to talk about today? Today I want to address three topics. Actually, I want to give you some insight into PKI, into public key infrastructure, and into CA basics, means a certificate authority basics. So it's just a broad overview, because I don't know what your knowledge about these topics right now. So I want to bring you all on the same level to see, okay, what's the problem with trust. After that, I will talk about the 2011 cases where DigiNotar, DigiCert and Komodo failed, and this was a really big failure, and I will talk about this afterwards. And lastly, I will talk about CA search, because on the one hand I'm standing here for CA cert, holding this talk and speech for CA cert, and on the other hand I want to show that there is an open alternative that is working different from those commercial CAs we're talking about today too. So let's start. Let's start with the PKI basics. Actually, public key infrastructure is always consisting of two parts. You have a public key and you have a private key. So to each public key there is one private key matching. The one who holds a secret, the private key, is the one who can encrypt, can decrypt everything that is sent. And the public key is, and that's the name in it, it's published. So it is public and everyone can use it to encrypt messages and send it to the one who holds a private key. So it means you have something you want to send in secret from Bob to Alice. Let's introduce them right now. So Bob and Alice are there. Bob holds a private key of Alice holds a private key. I'm sorry, and Bob has a public key of Alice. So she can send Bob an encrypted message by using her public key to encrypt the message and send it to her, and she can decrypt it by using her own private key. So actually that is the basic, and I won't go deeper inside, because that's everything you need to know. And I hope, sorry if you laugh, is it not everything you need to know about PK? Alright. Alright, so the second thing is we should know about is what is the CA, a certificate authority. A certificate authority actually consists of three major parts. So you have the registration authority, the certificate authority, and the repository. Someone, in our case it's Alice, is a subscriber. She holds a certificate, she subscribed at the registration authority. The registration authority is a legal unit that collects the data of Alice or any other subscriber and process it to get a certificate. The certificate authority itself publishes the certificate consisting or signing the keys given and the keys and stores the public key of Alice in a repository also as CLS. CLS are the revocation certificate revocation CRLs, the certificate revocation lists, where every certificate that is revocated, it's still stored inside. So and there's a relying party on every thing. That's Bob in our case. Bob wants to know, is the key of Alice still valid? And is it Alice who does the key belong to? So Bob is going to check it from the repository, gets the key, gets it is still valid, and can use it to sign to the subscriber. What is the most important part of what we're talking about today? It's not about the subscriber, it's not the relying party or the repository. These are the registration authority and the certificate authority. These are the main parts of the CA, and those assets need to be protected to validate and to keep the trust. How is it built? Actually, on the top it's a hierarchical CA. That means on the top you have a root CA. This is a root key stored from the certificate authority, and the root key is the most worthy asset the CA owns. From this one, sub-CAs, here we have two, are issued and assigned with the key of the root CA. Them can sign the user certificates, like here Alice, Bob, and up to E. I was just looking up for some names, so don't blame me on them. Actually, the root CA could give certificates for all of them directly, but normally there are sub-CAs for different cases, so we do it in a hierarchical way. And if someone wants to check if Alice's certificate is right, he has to check the whole chain, starting from Alice's certificate, signed by the sub-CA, signed by the root CA, because the only trust and the trust anchor is the root CA. Now we're getting in a problem, I think, because you know there's not only one CA, there are hundreds of CAs outside there, and you need to trust each of the CAs. And this is there are a lot of ways how this could be implemented. I brought to you two here, and I have another one in my head right now. This is cross-certified CAs. This means if there is one CA here, our root CA again, and there is a Fox CA, a second CA, they certify each other, so they have a cross-certification. That means if someone who's relying on Fox CA checks the certificate of Alice, is also relying on root CA, because they cross-certified each other. The second approach here is a bridged CA. A bridged CA means both CAs are independent, and on top of it, or between them, there's another CA where both CAs are relying to, and actually this is an enlargement of the hierarchical CA. So it means you have an additional entity inside you're not directly relying to, but it is bridging one CA to the other, and this is bringing additional value, because just imagine two CAs, they're cross-certified, but there are not two CAs outside. I said there are hundreds or thousands outside, and if each of them would cross-certify with each other, you have, I could say mathematically, we try to get it, but I don't want to back you with this. There are thousands, millions of connections between them because of the cross-certification. That's the reason why a bridged CA was established as one of the points, because every CA is just trusting in the bridged CA and not trusting in each other CA because it doesn't need to. So, what we have and what all of you might know is the browsers, the operating systems, they all shift default CAs. And actually they take away the decision if you trust the CA and if you trust the trust anchor or not. They're shifting it away from you to them. They say, we tell you, you trust root CA by default because we say it so. And that's actually a problem that got back to them on 2011. Because what happened on 2011? And now that's the point. You might have seen one of those, or all of those headlines on the net, and those are just some of them. It happened to, you see, we have Komodo here, we have DigiCert over there, we have DigiNotar. DigiNotar was, I think, the biggest case, actually. What happened to them? They have been in the browsers. That means you trusted them by default, and then there was different cases why hackers attacked them, and they got inside the systems. Sub-CAs, like at DigiCert. DigiCert is only a sub-CA of a different CA. They did not establish policies like the root CA, and you still trusted them because you trusted the root CA. So what happened to them? They had a data break, they had a fraud inside. And it happened because you trusted them by default, and you saw Firefox, you saw Chrome, you saw Chromium. They all shifted a patch to get them out of the registration, of the authority registration. So is trust the root of all evil? Now we're back to the topic. I just got some points why those CAs failed. And I'm not sure if this is all, but I think we have a big problem right now. We still have a big problem because browsers still trust these CAs. One of the main problems I want to address at this point is the basic verification of the subscriber. Has every one of you ever tried to get a certificate from one of the commercial CAs? How easy was it? No, it's not about the money you paid.
There are two levels. There's domain validation, where you just get validated on your domain name, for example. And,
Exactly.
And then there is the higher form of validation, where you actually check the papers of your company. You can send you papers from the Chamber of Commerce, say that you are signatory from your company, that you're allowed to ask it. And then you have even higher one with EVSSL, where they like suddenly do more to us.
All right. So I just
the lowest form is very easy, and the rest is very hard.
All right. I don't agree on you. The lowest form, you're right, is very easy. The lowest form is just you send an information about that you own the domain name, so it's like an email address. It's verified on the email address that you own the domain name, and then you get a certificate. You pay for it, of course. The second level, the higher level, is you send documents, but they cannot verify that the person who sent the documents is a person who says he is. And that's the actual problem with them. That's a very basic verification of the subscriber that fails.
Yeah. That's not entirely true. I had a passport check where somebody came to my door.
All right.
This face-to-face check if I was the guy on the passport.
All right. That's average, of course. Yeah. But I don't know it from all the CAs. So I didn't set all CAs do it, but okay, that's good to know that there are CAs who do a face-to-face check, because actually you pay a lot of money for it, so they should do it. That's right. The other point is, that's a big problem or big issue too, is reselling of CA services. This means there's a big CA like Komodo who is reselling their services to smaller CAs, but those CAs are not following the same rules and the same policy as Komodo. And this is what happened to cacert. Cacert was, I think it's Komodo, it's the main CA, but don't put me on this too hard. And Komodo has stricter rules and policies than cacert had. So cacert got this fraud, and so there was a question: can't we trust Komodo anymore too? It's a big issue. Anyway, some things we don't know about is weak keys. Do we know if there are weak keys used? We don't know. And server intrusions. Do we know if the root keys are protected, well protected? It's all about communications, and we don't know if the communication is as good as we're expecting it from a company we're giving our money to. So these are reasons why commercial CAs fails. And I say it again, they're still in the browsers, you still trust them by default. So what are the lessons learned from what I'm just talking about? It's what needs to be done in future, what should commercial CAs do, and what is the alternative to that. Of course, open policies, open governance is a very big topic, and it's a very big issue that should be done not only by CAs, but in the politics too, and in the open source community. And from open source communities, you might know it, open governance is one of the main topics, and it's mostly, they're mostly more open to everything than commercial companies. Transparent processes. You need to know what is happening on every step. You need to know are the processes documented and are them followed. IT security and data protection. Do you always know if your data is secured? Do you always know if the certs are saved? And how the root keys are saved? And of course, we talked about it, exact identity check. So, what we can offer from cacert is an open policy, an open governance CA that has built in those rules and those ideas from the lessons we learned. So this is a question I'm asking, how about cacert? And I try to say, what is our approach on registration authority and what is our approach on certificate authority? First of all, registration authority. Our registration authority follows policies, and each of you, everyone, can just check our website. The policies are open for everyone. You can even work with us on the policies, you can discuss with us on the policies, and we are open for input. So if you find anything where you say, alright, dudes, that's not great, or don't we need to change this? Come to us, send us an email, we will talk about it. The second thing is identification checks. We check your ID card, and that's what we're doing here in our on our stand in building K, on the ground floor there. We check your identities, and you'll need at least 2 assurers to get your identity checked and to get the validation that you're the one you state to be. Why 2 assurers? Or at least 2 assurers. This is the reason, not that we don't trust each other, but we're human. And we might do mistakes, or we might get bribed, or we might want to do this favor. Okay, we don't know. Is the other one really reliable or not? And this is all about our trust. And our trust model, we say, okay, you need at least 2. Why do I say at least? Because if you're a young assurer, if you're a new assurer, you can only issue a small amount of points, and at least you need 50 points to get a certificate with your name in it. So this means if you're young, you're more likely, or it doesn't mean young, if you're a new assurer, you're more likely to do mistakes. And to avoid this, we say, okay, you can issue less points, and if you're growing with it, and if you're getting major in your assurances, you can issue more points. So it makes the process. Actually, there are 2 points. One is it makes it more easy to get more points to get a senior assurer, but on the other hand, it makes it a bit fun, like hunting for points, and this is how we get the community inside again. And the last point is arbitration. That means we have our own arbitrational system. For each of you who has a complaint, can just come back to us and we check it, and we can speak a ruling about it. So how about our CA, our certificate authority? On everything we do, we have a 2-man rule. Means the keys, the root keys, the root key ceremony has to be done even by 2 men. Even the server maintenance has to be done by 2. One is always supervising the others. One cannot even do something without the others. We have open source code. Everything where our signers, our whole system is open source. It's documented open source. It's open for you to participate in it. And before we deploy our code, we test it and we do code reviews. So we guarantee that every piece of code that comes into our systems is be reviewed at least once. And we try to avoid getting thrown into our systems by malicious coding. And we have audit logs. Audit logs for certification creation means we have always the possibility to check what happened at what time, and these logs are not changeable from the outside, just from the certificate authority itself. Coming to the main question almost everyone is asking us, when does cacert get into the browsers? That's a good question. I cannot answer it, not now. But we need to gain trust. And there are 2 possibilities to get into the browsers. I always say it's spending a lot of money, or getting an audit done, what still costs a lot of money, and what has a lot to do with spending manpower. So if someone of you wants to work in a certificate authority, wants to work with a team who is highly into this topic, you're always welcome. Just visit us on our booth. And even if I cannot say when we are in the browsers, I can tell you we're working on it. And we're really working harder on it than we ever did. So you're welcome to participate. In the end, tomorrow at 12 o'clock at Farah, we have our cacert signing party. This means if you want to become part of our community, if you want to have free certificates, if you want to challenge us with questions, come there or come at our booth at the K building. Thank you for this, and I'm open for your questions.
You said it's not possible that one person alone can create or sign certificates, like, for example, a new intermediate certificate, right?
That's right.
So how do you make that? How do you assure that no person alone can do that?
This is covered by a policy too. You can read it. I don't have the whole policy in mind, but at least you have to be supervised. That means if a new sub-CA is issued, someone needs to supervise it and write down all the steps. We have a checklist, what needs to be done, and we follow this checklist. And every thing not done on this checklist must be written down. So this is how we ensure it.
So how are you sure you cannot be hacked like Kuchinota?
we cannot be sure that we cannot be hacked like DigiNotar. But what we can be sure of is that we have mechanisms to revoke the certificates faster than DigiNotar did it, and we have the mechanisms and the policies to inform the people faster than DigiNotar did it. Yep.
So, I mean, you didn't mention how do you get into browsers. So there is the CA browser forum. What is your take on this, Audit?
How do we get in the browsers?
Yeah.
Actually, I'm not.
Do you guys interact with the CA browser forum? Yes. You do. Okay.
Oh, it's the CA browser forum. Yeah, we do.
Okay.
But the CA browser forum actually is just one part. It's just a network of CA of certificate authorities. So there's much more than just them. So there are open standards we try to establish, and the CAB, the CA's browser forum, the CA forum, sorry, still has a bit different ruling than, or gave themselves a bit different ruling that is more for commercial CAs and is not one-to-one applicable on our system.
So I mean, I worked for the W3C. I know we have Python ITF in the audience, and I mean, given that the CA system has spectacularly fallen apart over the last 2 years, really obvious ways. And while I appreciate the work the CA starts doing, I do think it would be interest for many of the browser vendors, you know, WebKit, are open source, and also Microsoft, in fixing this. If there was actually a good technical solution that could prevent this sort of giant single attack surface the CA system currently has. But then there's a large amount of companies whose interest is not in fixing it, to be honest. And there's also, you know, it's a hard technical issue. There's no consensus. So, I mean, I appreciate the work, but the entire system is clearly flawed. So I would invite people to actually discuss this further. I know the IETF will be having a bar bomb on this in tomorrow. And I would appreciate if people came to that. It'll be on the IETF website, I think, fairly shortly. And that we do need, I mean, this entire system has to be fixed shortly, otherwise the web is undermined. And CA Cert doesn't fix it. You guys have an interesting system, but it doesn't, you know, it's still the entire system.
Yeah, that's true. Of course, there are problems we cannot fix.
Yeah,
definitely.
Exactly. And that's the goal of the community as a whole.
But thank you for your information about this.
I have a question. When you say the system needs to be fixed, are you strictly talking about the browser system? Because the certification system is broader than just going to a web page, right?
Yeah, I mean,
it's a WC3 really only concerned about the web, which is fine.
We are mostly concerned with the client-facing web, so the IETF would be the CA browser form for an actual place or actual certificate authority. We don't touch it. We probably would not touch it. At the same point, by saying entire system, we're talking about the fact that you can undermine a single CA and do anything you want. That's the problem. It's an attack surface. And then the revocation is a mess. So that's obvious.
The revocation system it's a main problem, but you should.
Really bad problem. So there's no clear solution.
You should discuss it in private, please. Yep.
And the discussion now concentrates on browsers. It's not only browsers that we use certificates for.
That's right.
We also use it for the discussion concentrates on browsers, but the certificate issue is not only browser related. I am working for ING Bank now, and we're in the business of transmission of files between banks and other organizations. And all those transmissions also are encrypted by using certificates. So it's a far broader issue than only the browsers and the web.
Definitely it is, but the front and the client actually mostly just sees the part of the browsers and the part of the email encryption. That are the two parts that are very common and very broadly seen. But you're right, definitely there are other software systems using certificates for encrypting and decrypting software messages. Sorry, and
but it is an issue as a whole, because the industry and the big banks and the other organizations that really rely on software and computing are gradually shifting from the paradigm that it can only be trusted if it's bought and if it's done by a party that can be held accountable for whatever. They are not there, not arrived at the point that they understand that, for instance, open source certificates generated by cacert are reliable as well. So this is a development in this industry.
I think there's one of our cacert guys who wants to answer it.
I know that at least in Germany, some bank features are already done with cacert certificates.
Okay.
In the background, not in the front end to the customer, but on the back side. I don't know for sure that is done quite often with cacert certificates.
And which bank is that?
Mainly also went to Bundesbank.
Because I know, for instance, that the Rabobank in the Netherlands is heavily relying on Red Hat Linux already, whereas other banks stick to some AI. In general, they stick to Oracle and the mainstream big commercial products.
That's a very interesting thing. Yeah, thank you for your contribution. Actually, getting this information, I want to pack it a bit. Other banks, there was the comment. Other banks are already using, like Rabobank, already using Linux on their desktops and on the server systems. Yeah, on the server systems, and I think most companies are using Linux on the server systems. What we offer too from CASA, I know it's a bit about advertisement, but I hope it's the right group to talk about. It's the organization assurance. That means that a whole organization can set its own its own CA service offered by cacert. So if you're interested in this, please just talk to us and we can offer it to you too.
I have a question. You just said a few slides ago that it's a problem that CAs outsource their activities and sub-CAs, and yet at the same time
we're not outsourcing outsourcing it in a sub-CA. So what we're doing is we're not issuing a sub-CA where the company can do whatever it wants to. It's still in our hand. So what we just do is we make it more easy for the company to issue a large amount of certificates.
Okay, some kind of API or something like that.
So, no, it's not an API. What we're doing is we're just putting the registration authority in the hand of the company, but we're never outsourcing our CA system. It's only the RA system that's outsourced to the company. So it means the proof and the liability for the registration lies at the organization, at the organization admin, and the organization administrator is an assurer himself, so he agrees on the policies that we gave. So that means he's in the same status as as every other of our assurers. So there's no difference; still the same policy. All right?
Okay.
Does that mean that you and only you hold all the private keys for all the intermediate certs in your hierarchy?
cacert does hold all the keys for the root and the sub-CAs.
All of them?
All of them.
Okay.
Yeah.
What does it take to get into the web browser?
Money.
Yeah, just asking. It's only a matter of money or something else?
Alright, okay, how do we get into the web browsers? Yeah, that's a question we're asking ourselves all the time. No. Actually, we know what needs to be done. What we need to do, and this is where we need money for, and what we need human resources, manpower for, is we need to get our software system through an audit. And we need to check our system against the criteria of the audit, and it's important that, and we don't want to fail, right? So we want to pass it at the first time. So we really want to check every piece of the system and correct if there are any errors inside or frauds inside. And so that's I say it again. We need you if you want to volunteer and help us in getting cacert into the browser.
Why don't you move where the movement is? because the movement is already at the Bundesbank. So why don't you start from there?
We're trying to get in contact with them. Because all these things are done on the lower level, not on the high levels.
Okay.
So that's the reason getting.
Okay, but a low level is also.
We're always working on it.
You're right. There's a second way to get into the browsers. It's about the mass. So the more people, the more companies use our certificate, the higher is the pressure on the browsers to get us to let us in. So you're definitely right. But still, the audit needs to be passed.
Okay.
Any more questions? Oh yeah.
So I don't know if this is.
Could you please speak a bit louder?
I don't know if this is something that CA Cert is working on or involved in, but it seems to me as though one of the big problems of the CA model is that a particular server presents a certificate from one CA. So you can't offer a CA Cert certificate on your server unless you believe all your users will accept it, and you don't have the pressure to have browsers ship your CA because no one's using it on their servers because their users of browsers won't accept it. And then once you are in the browsers, they effectively can't revoke the CA because there isn't, for every server that's using that CA, there is no alternative.
Right. So it looks like you're proposing an idea how to get into the browsers, is it? By grassroots movement. So it means like everyone needs to trust in websites.
No, I'm saying that if it was possible for a server to present, here is my public key signed by CA Cert and VeriSign or whatever.
Cross-signing.
You mean redundancy, having two certificates alternatively or installed on the server?
Yes. So, as long as the client trusts one of those CAs, they will consider it valid.
Just for information, I did just before this talk, the Audit gave a talk online, and live online. And as part of that talk, I also made that claim that we should introduce redundancy into that CA world, because that would allow us to actually revoke one of the CAs, even if it's too big to fail, which is currently the issue, that you cannot revoke one of the larger CAs without breaking the law to it. And I fully agree with you that introducing redundancy would be good, and one proposal could be to turn the SSL/TLS protocol with an additional handshake and say, okay, if the client didn't like the first certificate, you could say so in the TLS handshake and request the backup certificate.
Yeah.
But this is not yet designed. This is work that must be done in the future. If people agree to that, I would agree that we should get it done.
All right. Thanks for this comment on this. All right. Any more questions? In front here.
You run custom written software, or
do we run custom?
What do you use as certification authority? Software.
Oh, I need to give it to Uli. What kind?
Yeah,
it's all
written in 2003 by Juan.
Right. Yeah, it's custom written software. All custom written
is it
software.
available on some kind of repository and everything?
Yeah, it is definitely. It is open source. Everything is open source. All our systems. So you can check it on our website.
It's not cacert centric in terms that you can deploy it as certification authority for.
You could you could deploy it as your own certification authority, definitely. Okay. Yeah. Just visit our website and search for it. I don't have it.
About cacert, you find it.
In about cacert, yeah.
Okay.
All right. Thanks. There was one more question over there. Yeah. In the middle.
A couple of questions. First is, so you're using open source software, but I guess you're using a commercial HSM, right? Hardware security module?
License?
Hardware security module? HSM?
Where do you store your private key?
The question is your private key protected inside a hardware security device so no one can copy your private key?
Right.
Is that your question?
That's my. Well, I assumed it was.
All right. All right. Right now it's stored in software, but we're going to, or we're planning to move it into hardware cryptographic devices. There is a planning right now. We know now it's in software. It's less safe than to keep it in hardware. But the signer itself, so the machine who is signing the keys, is not attached to the internet. At least the root server is not attached to the internet. If it's not really necessary.
Well, using hardware encryption protects you against an insider attack, which kind of goes back to someone else's question.
That's
about
right.
How do you know you're not being hacked? Now, you don't know. You can hope.
How can you hack a system that's not, that you can only reach physically, not via the net?
You can reach it physically.
No, it cannot be reached.
No, it can only.
It's not possible to enter the place.
Yes, but sir, how do you you have to sign your certification list every 4 hours? How can you do that if it's not attached to the internet?
We're talking about the root keys. The root keys is not.
Certification list every 4 hours. It's updated every 4 hours. God knows why. It has to do so. So you have to sign every 4 hours
that's
on the web.
That's what I said. It's only connected to the net if it's really necessary. It's a local network. It's a local network. It's shifted, so it's not directly connected to the internet. Definitely not. You're right. There is a problem. We know about it.
Okay.
You have to go. Yeah. You have to go through the network to find it. Okay.
My next question is about
There is no network
Oh, sorry?
connection.
There's no network connection. I'm not a critical system admin, so I don't know about.
No. It's going via serial line, so it means it's not in the usual network. You cannot simply access. Also, you cannot enter simply the room or get connected, get physically there. It's not possible. You need a number of guys. You need a number of entering systems to get actually even physically there.
Okay. So no one has the key to get to that box by themselves.
It's not possible by a single person to enter.
Okay.
Always two-man policy, and okay, it's a serial line, so it was just one directional. All right.
The second question is how transparent are your operations? Do you publish a log of every time someone requests a certificate and things like that?
Do we publish a log? We don't publish the audit log. Should we?
In the policies, there are definitions that every identified external access break has to be reported to the executive and brought into arbitration. So at a short time. Otherwise, the critical admins and access engineers are violating policies.
I guess I'm just wondering about the policy, the possibility for anyone on the internet to do an audit of what's going on within cacert. If that's in any way possible.
Right now,
that would increase the trust. We don't have to trust some third-party auditor or audit. If someone is issuing third-party certificates, then that would increase.
What about privacy? I wouldn't want everybody on the internet to know that.
That's a valid point. What about privacy? So
that was my next one.
Okay, if you issue the audit log, so this means a log where every operation of the signer is stored. How can you ensure privacy? And I think this is a problem. What we do is every arbitration case that's ruled by us is published openly. The only thing you cannot see is names and email addresses. Everything else is published openly. So you can browse our wiki, and every arbitration case we ever did is stored there.
I guess we're going a bit into policy discussions, but the process of establishing identity is by nature non-private. Right? Asking someone else to declare that you are a person, and they're declaring it somehow. So,
how do other CAs?
I don't know. I assume other CAs.
Okay, actually, this is a valid point. I'd like to shift this discussion to our booth. Just visit us, and we can talk about it.
I can give you an example. For example, the certification center in Estonia, who runs the national PKI, actually does have a public secure hash load. So it is possible technically.
All right.
Yeah.
Okay. So we should talk about it, and we can make us more transparent. If you want it. So actually, I'm over time. I would say thank you first, and we can discuss later because this was the last talk. So who wants to stay can stay. And just our information, visit us at serious.org.
Could you please add two digits at the board?
Okay.